All right. So let's get started with our project number 9. And this project, again, I picked up for computer vision. And this project deals with, again, healthcare data set. As you are seeing, that we are looking forward to detect melanoma disease. That is what I have explored so far, is a skin disease. Okay, so we are available with the data set, skin data set, which are having that kind of a tumor. It's like a cancer, skin cancer. That's what we are calling melanoma. And the data set which we are having right now, I'm showing you the title of the project. And it comprises of 13,900 high resolution images. For enhanced diagnosis and classification, we are looking forward for, we have to use our machine learning techniques to automatically detect whether the skin is having a cancer, or whether the skin is having this disease or not. Okay, fine. So first, I put a detailed overview of this disease because domain knowledge is important. As we have seen in each and every project, first of all, we discuss about the domain. Okay, so melanoma is a type of skin cancer that develops from pigment producing cells known as melanocytes. Okay, so it produces such kind of cells in the skin. Okay, and that forms pigments. These cells are responsible for producing melanin, the pigment that gives skin its color. While melanoma is less common than other types of skin cancer, it is most serious and potentially deadly because it can spread. That is the issue. This cancer can spread if it is not detected or treated early. Okay. So, pigments, which are called as melanocytes, these are developed in the skin because of this disease called as melanoma. There are various types of melanoma: superficial spreading, nodular, lentigo, acral, amelanotic. All are biological medical names, may be tough for pronunciation. Okay, these are the classes. Like in the first one, 70% of the disease tends to outward along the top layer. Then the next one is vertically into the skin. Then the next one tends to develop on sun damaged skin, face, and the arms. Okay, this one is rare but common in people with dark skin tones, and this is less common form, lacks pigmentation, making it harder to diagnose. It may appear pink, red, or even skin colored. So these are the various forms of skin cancers, melanoma. If I do talk about the causes, why this kind of cancer happens, so damage in the DNA. Okay, it can leads to uncontrolled growth and cancer, and the risk of developing this disease because of ultraviolet rays exposure. So right now, as you know, that our ozone O3 is being depleting, because of the pollution. So ultraviolet rays can enter into the earth's atmosphere. Obviously our skin will be exposed to such kind of radiation. People with fair skin, light colored eyes, hair, and those who burn easily in the sun. So remember, sun, take care from the sun. Moles. Moles can convert into melanoma. Yes. This is, I will put a star mark here. Okay, don't consider that okay, moles are just okay normal. No. If they are increasing and if there is a pain, so I think consultation is required. Family history, okay, that is something is common. History of sunburn, weak, weakened immune. See, if human immune system is weak, then a person can be exposed to any kind of disease. Age also, the risk of melanoma increases with age, but it can occur in young people also. Okay, so these are some reasons. Symptoms: melanoma can develop anywhere on the body. Okay, skin. No? If it is exposed to sun, then face, arms, back, legs, anywhere it can be uh, there. Okay, so it may also appear on less exposed areas also, like feet, palms, on the hands also. So the ABCD rule is a common method to identify potential. ABCD rule. What is this ABCDE rule? A means asymmetry. One half of the mole or a skin is lesion doesn't match the another half. Okay, on skin, one side color is different, another side color is different. B. Border. Melanomas often have irregular notched or blurred border. Okay, so border is nose or blurred. C. Color. The color may be uneven with shades of brown, black, red, white, or blue. Such kind of colors can be there. Diameter. They are often larger than 6 mm, about the size of a pencil or eraser, but can be smaller when first detected. Can be, but 6 mm is something, and it is evolving. A mole or lesion changes its size, shape, color. Okay, that's what I told. Remember. Then okay, you have to consult. This is, this could be a symptom of skin cancer. Signs: sores, redness, changes in sensation, itchiness, tiredness, pain. So physical examination can be there of the skin, followed by biopsy if suspicious lesion is identified. Okay, then there will be like treatment or like operation can also be done. Okay, that can remove that particular part. Okay, so there are certain biopsy, the entire mole is removed or part is removed or small piece is removed, whatever. Stages, there could be, see, cancer do have stages, so this is also kind of a cancer. Stage 0 to stage 4. एंड इन, अच्छा ये फिल्मों में काफ़ी डराता है ये कैंसर और ये जो स्टेज स्टेज है ना, तो हमें वो फिल्मों में इन टीवी सीरियल्स में, ओके, इन हिंदी सीरियल्स और इन द मूवीज, ओके, व्हेन इट कम्स, अरे आपको तो कैंसर है, पता ही नहीं चला, थर्ड लेवल पे आ गया, फोर्थ लेवल पे आ गया, और वहां पर वो पूरी इमोशन इमोशन और ड्रामा निकल के आ जाता है सामने। ओके, और यहाँ पर मेंशन कर रहे हो, होता है ऐसा। ठीक, तो स्टेज 0, द कैंसर इज कन्फाइंड, पता नहीं चला, ट्यूमर बन गया थोड़ा सा। ओके, देन स्टेज 2 थिकर, ओके, थोड़ा सा लगा यार दर्द दर्द हो रहा, थर्ड पर आ गया तब, व्हेन इट गेट पता चला डायग्नोसिस में, तो स्टेज 3 हो गया। देन स्टेज 4 इज स्प्रेड हो गया, स्प्रेड 4 टू लंग्स, लीवर, ब्रेन, अब तो बचने की संभावना ही, ठीक है, तो ऑब्वियसली थेरेपीज आर रिक्वायर्ड होती है। पता नहीं, अब देखो ट्रीटमेंट में बोल रहे हैं ना, सर्जरी है, okay, operation needs to be there, then sentinel biopsy is there, therapy is there, है ना, ये बोला था मैंने, checkpoint inhibitors will be having the therapy for that, targeted therapy is also there, Okay, specific mutations, specific like drugs like these are used for the therapy. We can have a radiation therapy also. Okay, so melanoma can spread. Okay, so such as brain or the bones, so we can use the targeted areas for the therapy. कई समय तक चलती है. Okay, so chemotherapy is also there. For cancer, chemotherapy is common. Okay, so one of the not as commonly used, लेकिन मेरे को तो कीमोथेरेपी का तो सुना है मैंने काफ़ी ज़्यादा. अच्छा, मेलानोमा के लिए नॉट कॉमन है. ओके, बट ऐसे तो कैंसर के लिए कीमोथेरेपी इज समथिंग कॉमन. एंड टुडे ड्यू टू एडवांसमेंट्स इन इम्यूनोथेरेपी, ओके देन फिर ठीक है. इन इम्यूनोथेरेपी इफ देयर इज एडवांसमेंट देन कीमोथेरेपी नहीं कर रहे, बाल बाल उड़ जाते हैं उसमें. ये कुछ ऐसी चीज़ें कीमोथेरेपी. Prognosis. Okay, the prognosis for melanoma depends largely on the stage. Early stage, okay, has an excellent prognosis with a 5-year survival rate close to 100% after surgical removal. Okay, cancer में भी there is an issue. Okay, with cancer आप मतलब जो है जो पेशेंट है आफ्टर डायग्नोसिस ऐसा ना हो कि स्प्रेड और तेजी से हो जाए. If we can control the spread, okay, then survival rate is high. And if the melanoma is in high stages, 3 and the 4, poor prognosis, especially if it can spread, then difficult. Okay, okay, including have dramatically. Okay, अभी ये कह रहा है advanced melanoma. For poor prognosis, especially if it has spread to distant organs. However, never therapy has been taken, including immunotherapy, have dramatically improved survival rates for some patients. For some patients, survival can be there, but dangers always present. Danger is always there. So थेरेपी भी बहुत सोच समझ के लेना पड़ती है यहाँ पे. ये उल्टा ना पड़ जाए. थेरेपी कैन नॉट बी लाइक बिहेव अपोजिट टू द डिजीज. ओके, ओनली द इशू इज स्प्रेड. सो प्रिवेंशन, ओके, लिमिट सनलाइट एक्सपोजर. भाई हम तो इंडिया में रहते हैं, तो इंडिया में तो वैसी गर्मी बहुत पड़ती, गजब की पड़ती. समर समर सीजन में तो मजे ही आ जाएंगे आपको. ठीक है, तो 10 AM to 4 PM में आप एसी चलाएं. ठीक है, और चलाओगे तो ग्लोबल वार्मिंग. इफ़ यू यूज़ द एसी देन वो गैसेस जो रिलीज करेगा वो ओजोन से रिएक्ट करके वो डिप्लिश कर देगा उसे. देन अल्ट्रा वायलेट रेज तो घूम फिर के फिर वही स्किन कैंसर पे ही आना अल्ट्रा वायलेट रेज से. ठीक है, यूज सनस्क्रीन. ठीक है, लोशन वोशन लगाएंगे. वियर प्रोटेक्टिव क्लोथिंग लगाते ही हैं. वी हैव सीन द पीपल डू वियर ऑल दिस, मतलब वो पूरा पैक करके रखते हैं. ओके, टेनिंग बैट्स लेट मीन्स यूवी रेडिएशन से बचने के लिए रेगुलर स्किन चेकअप करते रहो. ठीक है, ये वाली बात. फाइन. सो यू कैन सी लाइक सच काइंड ऑफ, यू कैन सी ना दिस डायग्राम, दिस इमेज. ओके, तो ये स्किन कैंसर का एक एग्जाम्पल है. So artificial intelligence and machine learning can play a critical role in early detection. कर सकते हैं, और यही काम चल रहा है अभी. Okay, so we do have a data set in regards to it, so that okay, images are present, skin cancer and non, okay, benign and the malignant. Actually we are having two categories, benign and malignant in the data. I'm just discussing right now only. This is the image for the skin cancer, you can see. Okay, fine. So the data set, in our data set, as per the title itself said, 13,900 high resolution images we are available. Okay, and the dimension is already high, 224. Okay, the data set is aimed for improving early detection and accurate diagnosis of melanoma, a dangerous form of skin cancer. Okay, it serves as a resource for researchers and machine learning practitioners to build robust models capable of distinguishing benign and the malignant. See, benign means, see, malignant is dangerous. Benign is not. That means there it is present, It is present, but not harmful. Malignant is harmful. I have seen these two terms in breast cancer also. Benign and malignant. If you know, if you have done the project on breast cancer, there also we do have benign and malignant. Okay, so here also same thing they are mentioning benign. Okay, not dangerous, while malignant is dangerous. That can spread. Benign will not spread. Malignant will spread. Okay, if the something is not spreading, so we can have a control and we can treat. Something which is spreading, that's an issue. So melanoma requires prompt diagnosis. Every cancer require. Machine learning models can perform computer-aided diagnosis. Computer vision can help us in early detection. The dataset address the complexity of the melanoma diagnosis, which can be challenging due to varied appearance. अब भाई स्किन पे है और अपीयरेंस स्किन में कलर कैसा क्या है वो चैलेंजिंग है ये तो. So uniform image size, high quality, comprehensive range of melanoma ensures the data set for us to apply the machine learning techniques and algorithms. So the images are drawn for multiple sources, okay? From diverse cases, they have taken the images which are available on the Kaggle related to skin lesions, okay? And this is a challenge actually on the Kaggle, and we are taking this challenge to use our machine learning techniques, and we are looking forward to classify between benign and the malignant. Okay, so we can download, explore the data set, we can apply machine learning algorithms, and that's what we can contribute. Okay, so inspiration is apply need for advanced dermatology tools, especially for diagnosis, by sharing its foster collaboration with the community. So this is what mentioned on the Kaggle when they are describing about the data set. Okay, so about the disease, we are now clear that you are dealing with skin cancer data, which is having 13,900 high quality images. It is having two category, benign and malignant. Benign is, as I told, it's not spreading, but malignant will spread. Okay, fine. And obviously, we need to classify between them. And there is a question of early detection. Early detection. Early detection, what it requires is are you monitoring something over a period of time? Are you monitoring something from a period of over a period of time? For example, for few months, I am checking that is there any change. So early detection will be like if you can identify the change, that will be early. However, at this particular moment of time, I'm all available. What I can do is I can train my model and I can perform the classification, whether it's benign, whether it's malignant. That's what I can do. Whether it will account to early detection or not, that is a question. Is it related to time? I don't have any time data. I'm just having a data, not bound of time. I'm having two classes. Can I justify this thing as early detection? Well, according to me, if I think I require time data on this particular time, okay, this is benign and this is malignant. This is benign, this is malignant. This is benign, this is malignant. So then I can do something for early detection. Right now, I'm available with the images, and my model can only predict what's going on. Okay, fine. Let me show you the data set. So this is my data set. Okay, here it is. Melanoma cancer image data set. It's available on Kaggle. Okay, here you can see Benning tumor. See, Benning is also a tumor. Don't think that it is not a cancer. Benning is also a cancer. Malignant is also a cancer. But Benning will not spread. You can see it is concentrated here. So I can have a quick treatment. Malignant spread. Okay, got it. It's spreading. Fine. So I need to utilize this data set, and you can see all the details are mentioned here. And here it is, Benning and the malignant. You can see the images. Fine. So these are the images. Okay, they have collected from various sources, and both are cancer images only. Okay, this is Benning, and this is malignant. Okay, it's more spread. So it looks like dangerous. Okay. Anyways, we have to work on this data. It's challenge for us, but we have to. So cancer is not an easy disease to tackle, but we are using our machine learning techniques. Okay, that's what we are made for, to apply AI and help. Okay, so this is the code which I did. Okay, fine. So here is the code, and same thing. What I proceeded yesterday, I give you so many tips for bone fracture. Still, we are dealing with the medical or healthcare data only. We are okay. The first thing is image, second is medical. Okay, so today I totally utilized my previous lecture quotes. See, first I imported my data. Okay, this is my data. Benning and the malignant. I took all the data. Okay, after that, hmm, after that, this is the path. Where is the malignant directory? Where is the Benning directory? Where images are present? This is the path. Then, after taking the path, I counted the number of images which are present in each and every. Okay, fine. Why you guys are silent then? Okay, now I'm sharing the entire screen. Okay, तो आपको मेरी आवाज़ अच्छी लग रही थी तो चुप थे बस. Okay, I hope now you can see the code. See, this is the data set which I have shown you. You are not interrupting me also. Okay, so this is the data set, melanoma cancer image data set. Sometimes na, I am in a flow, so I forgot to share the entire screen. Okay, so here it is. On Kegel, melanoma cancer image data set. And this is benign tumor and this is malignant tumor. Okay, fine. And here I have shown this is malignant. You can see the cancer, skin cancer. This is how it looks, malignant, which is spreading. And then I do have here benign also. This is benign. Okay, this is benign. Okay, benign. Okay, so this is how it looks. So it's a kind of a skin cancer, and I took this data set for my implementation. Okay, and here I imported my data set. This is the directory in which the images are present, malignant directory, benign directory. Okay, and then I want to count the number of images which are present in the directory. Okay, so and I took training only. No, this is my training. I took training malignant and training benign, not the testing one. Training I took. Okay, fine. And then I counted how many images are present here in training malignant and training benign. Okay, so you have to just prepare the list and you have to count them. That's it. Just find the length. Yesterday also I did the same kind of code. Today, okay, just only a few statements can be different, but coding style can be different. But the approach is all same. Just make the list of all the images which are present. Okay, and then you have to just like perform the counting. I just prepared the list here, and image labels are malignant images plus benign images. Okay, malignant plus benign images. These are the labels. And here I called one column as image data. So what I am doing, I am looking forward to create a data frame. That's what I am looking forward for. Okay, yesterday I told you, even though you are available with images data, that means they are present in different folders. Do one thing, kindly create data frame. That will help us. So I am doing the same thing. I am creating data frame. Okay, so here just prepare the list of malignant images. I can put len also outside, so that will tell me the count. I will do later on. And here also I am preparing the list of benign images. Okay, and joining all the path of every images, I am tagging them as benign, and here I am tagging them as malignant. And image labels are malignant images plus benign images. Here I am taking the image. Okay, load the image path, malignant and the benign, load them. Where the images are present, load the path, and then create a data frame. Pd.data frame image data columns will be image path and the label. Okay, image path and the label. So here it is. You can see this is the image path and this is the label. Okay, so I am for image in directory. Pick image by image, put them in a list. Okay, put them in a list. This is your path where that image is present. This is the label which you have to give, malignant. Here you have to give benign. Create a data frame. Here it is. Image path label. Image path label. Okay, so malignant and benign. Okay, df.shape 11,879 images, two column. Column names image path label. There are no null values, there are no duplicate values. So this is what I do with a regular project also. When I do have a data frame, I do the same thing. Here also I'm doing the same thing because I have converted it into a data frame. So you guys are here to learn some skills, how things can be made easy. If you are available with the images, what you have to do, so make a data frame, prepare. What is the path? What is the label? Path label. The path where image is present and tag it. So this is how you have to make a data frame. Path and the label. This is the entire path and this is label. Malignant. Entire path benign. Okay. Now things will be easy. Okay. Then what I did? Okay, no duplicate, no null value. Unique values in label are malignant and the benign, and the value counts are for benign it is 6289, malignant it is 5590. So malignant is less than the benign. Okay, anyways, a little bit less, 700 images or less. Okay, so let's do something. Let's make a count plot for it. So here I made a count plot. Very well, very easy. I hope you know about these things. I do share the projects on regular basis on LinkedIn also, where in classification problems we do the count plot. Okay, so this is the count plot. Okay, for malignant and the benign, and this is the pi plot for malignant and the benign. Okay, basic visualization which I can do. Okay, so we understood that it's a binary classification problem. Two classes are there. So simple codes I have used for count plot and the pi plot. And then I displayed five images from each folder. So this is malignant and benign. Okay, prepare the list of images which are present in the directory. Randomly select any five images. Randomly select any five images from this list and make a plot. Plot them. This is the plotting code. See again, अभी मेरा टारगेट आपको पाइथन सिखाने का थोड़ी ना है. My target is not to make you learn Python, how to do a code. See, this code is not so much like complicated. You should know the approach what to do next, then what to do next. First, the first and the अभी code इतना challenge नहीं है मेरे लिए. Coding is not at all challenge. What is important for me as a data scientist at this particular time is data understanding. ये तो हमेशा रहेगा. Data understanding ये इंपॉर्टेंट है. सेकेंड इंपॉर्टेंट है कॉन्सेप्ट्स. दैट मीन्स लॉजिक्स आपको ये पता आना चाहिए. यू शुड नो what is the kind of data I do have and what steps I need to perform over that data. ओके ठीक है. तो कोडिंग आपको नहीं भी आता हो लेकिन कोड में आप पता कर लो. यू डोंट नो द कोडिंग बट व्हाट इज प्रेजेंट इन द कोड, व्हाट इज हैपनिंग इन द कोड, ये आपको समझ में आना चाहिए. And that's what the NVIDIA CEO says. I think I forgot the name or I guess I can't pronounce the name. Like मुझे अभी याद नहीं है. वो यही कह रहे थे कि everyone should learn computer science first of all. और कोडिंग को इतना वो नहीं, क्योंकि आप यू आर हैविंग ऑलरेडी हैविंग द टूल्स. आपको कॉन्सेप्ट लॉजिक आना चाहिए. हाँ, कोडिंग में भी आपको इतना घुसना नहीं है. व्हाट द स्टेप्स आर रिटन, वो क्या काम करते हैं ये आपको पता होना चाहिए. दैट मीन्स फॉर एग्जांपल, अब मुझे पूरा फ्लो पता है मेरे प्रोजेक्ट का, आप कभी भी पूछ लो मुझसे. एंड प्रैक्टिस करते करते आई लर्न बाय डूइंग द प्रैक्टिस दैट कि व्हाट इज द इजी वे टू सॉल्व अ प्रॉब्लम, इजी वे टू सॉल्व, ये मैं सीख गया. और आपको भी ये बता रहा हूँ कि डेटा फ्रेम बना लो. ठीक है, क्रिएट अ डेटा फ्रेम. फिर डेटा फ्रेम बन गया, देन काउंट प्लॉट कर दो, पाई प्लॉट, काउंट प्लॉट, पाई प्लॉट. ओके, दिस यू कैन प्रिपेयर. डिस्प्ले फाइव इमेजेस फ्रॉम ईच फोल्डर, ये कर दो आप, दैट इज ईच कैटेगरी. फाइव इमेजेस डिस्प्ले कर दो. सो दैट्स व्हाट आई एम डूइंग. सी, displaying five images from each, five from malignant and five from benign. That means okay, everything is perfect and yes, I got the correct path and images are okay, high quality images and I can see them. You can put this in your research also, in your project also. ये पूरा ऐसे ही फ्लो बनाना है, पूरा मेथोडोलॉजी. ओके, हो गया. ये इमेजेस डिस्प्ले कर दिया. Then okay, then my data was unbalanced, a slight unbalanced, so I use random oversampler. Yesterday also in my code I use random oversampling technique. Today also I'm using oversampling technique. Okay, I give my image path and label to ROS random oversampler. I'm giving this thing. Okay, so it will resample my data. Okay, and then I'm going to create a new data frame, df resampled. And you can check now the distribution of the classes 6289, 6289. Perfect. Balanced. I don't want to take a risk with unbalancing data. Let it be. हाँ डुप्लीकेट क्रिएट करेगा ना, कर दे भाई, नया कहाँ से लाऊं मैं? कर दे तो ओवर सैम्पलिंग कर दे भाई, डुप्लीकेट बना दे लेकिन बराबर कर दे। ठीक है, just keep make the numbers equal. You will create duplicate, okay, I don't bother, create some duplicates are, I can't bring the new images no. Medical the one of the challenge in medical data is you are you have to face again problems. Medical data is confidential data, no one is going to share this medical data easily, so it's a challenge. So whatever I'm getting now, and that is why generative AI is used. I can recreate these images using jans or auto encoders, decoder, transformer. Okay, I can recreate. Fine, so this is the distribution. Now fix. Then these are the libraries, the same libraries which I have used yesterday also. TensorFlow and everything. Convolution. Okay, all these. Fine. Yesterday also same libraries I used. And then what I did is I splitted my data into training, testing, and the validation. Yesterday also I explained. My initial data is DF balanced. Okay. DF balanced is my data. I'm splitting it into training and temp. This temp I will divide into testing and valid. Okay, so 80% of the data I will take for training, then rest 20% is in temp. Out of this 50-50% will be distributed into test and valid. That means 10% here and 10% here. This is how I am performing the distribution. You can see train DF, temp DF new, train test split, train size 80. Shuffle, yes. Shuffling I will do. With training I will do shuffling. With validation I will do shuffling. Okay, here also I'm putting a shuffle. After that, okay, now I have trained test data. Then I can perform pre-processing over the images. Here you can apply many things. You can rotate the image, you can flip the image, horizontal, vertical, whatever you want to do, you can. Shear, whatever be the transformations. There are many transformations, 10 to 15 transform, 15 to there can be many more. 10 plus transformations are there. There are 4 to 5 regular transformations which are used. I am not using anyone. I'm just using this code. I want to scale my data. That is normalization divided by 120, divided by 255. Rescale. I am having color images, so channel 3. Size is 224. Batch size is 16. I am keeping this batch size 16. Okay. This is train generator. Class mode binary, color mode RGB. Shuffle true. So training data, shuffle. Validation data, same, shuffle. Color mode RGB, class mode binary, because we are dealing binary classification. Na? Two ही classes थे ना, two. Benign and malignant. Okay, so create this validation data also by performing all these things. Then test data. Shuffle false. टेस्ट में shuffle नहीं करना है ना, गलती हो जाएगी. Okay, baki sab same, everything is same. This is what I've got. Then you can create your model architecture. Take TensorFlow, Keras, layer, early stopping. Okay, look out for the GPU. Obviously, I need to work on GPU, graphics processing unit. Okay, so for the computations during training, all right. So GPU are present. I took T4 cross 2 GPU I took. This is the architecture. Now, from two projects, I'm seeing success in this architecture at initial level. Not two. I guess there is one more project I'm doing my side personally. There also I got the success. In yesterday, I got success on this architecture with training and the validation, but on testing it got failed. Anyways, this is the architecture again I'm picking, and I think it fits best with 224 224. There's something in this architecture. Okay, so I am taking here convolution 32, then convolution 64, then convolution 128, and then flatten. Okay, fine. Activation relu will be there. Max pooling will be there. So it's a regular architecture. Okay. All right, all right. Number of classes. Number of classes. That's not required. That is not required because here we are taking one neuron for classification. Sigmoid activation function. Okay, so that is not required. Okay, quick save. All right, fine. So that is the architecture which I built, and this is the summary of the architecture. I use early stopping in case when your model is not progressing, when the losses are not being reduced, then you can stop. No need to run rest of the EPOS. Okay, so early stopping. Here I perform the training. Okay, and 10 iterations I took. Accuracy is 90% for the training, 87 for validation. In this architecture, I haven't used any dropout, any regularization, nothing to prevent overfitting. Not too much overfitting has been seen. Okay, though there is fluctuation, you can see these fluctuations in the plots. This is accuracy plot. This is loss. So accuracy is increasing. Validation, there is a fluctuation. There might be some set of data where models struggle to classify. But anyways, let it be. Okay. Here loss is reducing, but validation loss again fluctuate. Again, there is some data where model is struggling to identify benign or malignant. Then I thought, okay, with training validation, I got 90%. Let's test. So I performed the testing. Okay, in testing, that made me happy. 87% is the accuracy. With this simple architecture over test data. Okay, training validation is already good. With test also, I'm getting 87% accuracy. Okay, so I think I got success in the first architecture only. What more I require? Do I need to increase the accuracy to 90 plus? Okay, let's see what will happen. This is confusion matrix. I am looking forward to change the architecture. If it's possible, let's change the architecture so I can have less misclassifications. I will do that. This is confusion matrix. Okay, and I need to put a change. That means, okay, this is fractured, non-fractured. That is the same one, but I will do a change. Okay, then I applied regularization from my side only. Though my model is not showing that much overfitting, but some images my model struggled. So what I did is I included regularizer, L1, L2, this is L2, rich regularization. I included dropout also from my side. Let's include dropout also, and regularization also, to prevent overfitting in the model. Though it is not, but my model struggled, but that's the reason. Okay, I just applied this regularization, dropout and regularization. I extended my architecture with this layers. And what I found is, again, I trained my model, and with 5 iterations, I reached till 83% accuracy in training and 83 in validation. That means both are in contest, both are nearly same with 5 iteration, because I have already used early stopping, so it will not go to 10. Okay, so here it is, the plot. You can see this is the plot. Now validation is also increasing. It reached at this particular point, it is more than the training. Here also it is more than the training. There is some sort of data where it struggled here. Then it is okay till 5. This is loss. It is better than the previous one. Okay, it is better than the previous. Let's check the confusion matrix. So here 79% is the accuracy I'm getting. Previously I got the accuracy of about 87%. Now I'm getting 79 because I have already made my model to have regularization drop out these layers, so it will not get more. So 79 is the accuracy with this model, this architecture. And if I see the results, 398 231, ये ब्लंडर है. 398 231, ये तो बहुत ज़्यादा मिसक्लासिफिकेशन हो गया. So it's getting confused, this architecture, with regularization. It is getting confused in the skin cancer, benign and the malignant. Then I used exception, the one which was proved to be the best in the previous project. Exception. Na? In the previous project, we struggled with each and every architecture. Resonate, struggle. Efficient net, struggle. Common architecture, CNN, struggle. Exception. Exception with noise. Okay, you can see. I use this exception, same architecture. Same, no change at all. Okay, and then I trained this model. Exception. It went to 10 iterations. 92% is the accuracy for training, 89% for the validation. Okay, and it's perfectly fine. If you see the stats here, they are good. Then I plotted for the accuracy and the loss. You can see now there is not much fluctuation. There is smoothness. Only some portion I can have a struggle. rest it is smooth, training is smooth, training loss is smooth, validation I do have something, but okay, fine, not that much as we have seen previously. There could be a chance we can improve, but what I have seen is when we are having Gaussian noise, it is doing something better. Okay, and when I performed the confusion matrix and the classification report check, here you can see 89% accuracy. That means it is more than the regular one, 89%. Previous one was 87, the first architecture. This is 89. On 10 iterations, we reached till 89% accuracy for skin cancer classification detection using exception with Gaussian noise, transfer learning. This is something a good success. All three models, they are having good accuracies. This is the highest with exception. And if I do make confusion matrix, now you can see this is the best one. 582, only 47 misclassification. 532, 97 misclassification for benign and the malignant. Still, there is a chance of improvement. We can proceed by upgrading this exception architecture only. Okay, Gaussian noise, either we can it's 0.25, we can see whether increasing or decreasing can help us. Okay, we can also remove the Gaussian noise. That can also be one of the chance. Okay, there is a drop. Okay, we are using dropout also for the regularization, preventing overfitting. Okay, so we can do some changes in this exception. We can increase the layers also if it is possible. How we can reduce here dense 512, we can use 256 and we can add one more dense layer with the neurons like 128. We can increase this architecture, update this architecture, and we can see what could be a possibility. With this, I'm getting good results at the moment. Okay, and next I can try with the image to perform the prediction. We can upload an image and we can try for that whether the detection is getting proper or not. That's what we can do. So this is the confusion matrix. So far I have done this much part of the code. Three algorithms over skin cancer. Okay, fine. All right. Well, that's what I have to discuss today. Is there a way for us to understand why one model is better than the another? Sir, we can use explainable AI. That's a good question. Explainable AI we can use. Okay, so what features are better, which contributed a lot in the model development? So, sir, explainable AI is something, and there are algorithms like techniques like SHARP, SHA, SHARP. Explainable AI will tell that which feature is responsible, which features are highly contributing for the model development. Okay, so we do find in a feature importance using decision tree, random forest. Okay, so something like that. Explainable AI we can use. Okay, and SHAP is one of the technique. There are other techniques also which can be used. Okay, so that thing can be checked. So why one model is better than the another? Because of the architecture, because of the feature extraction it did. Okay, good question, and that's what I think that's a preferred answer. Okay, please, sir, find out the inference time. Inference time for what? Inference time is inference time. How much model is taking for the training or for the detection if you upload any image for it? Okay, model execution. Okay, fine, I got it. Okay, if you want to give any image for the prediction, how much time it is taking to give you a detection. All right, all right. So one is explainable AI, another is model execution, inference time you are asking. Okay, fine, I'll look out for that, and I'll try to incorporate in this code for the next tomorrow. Okay, and I will also incorporate other algorithms, and then we can have a comparative plot. Okay, that's what I will do. And all the codes are available on my Kaggle. You can check out. These are I shared publicly. Okay, these are my public codes, so you can check out the code from Kaggle. You can run these codes, and if you want, you can modify also. It's up to you. You can do that. Okay, fine. So yes, that's what I want to explain today. Thank you.